Hey gang, this was a super fun project. I took my Benchcrafted front vise and the hand wheel, I converted it from a single knob to more of a captain's helm style. So the current Benchcrafted wheel for the front vise is a 3-knob, but it will not retrofit the older style single knob Acme thread shaft. However, using the old wheel and converting it to a 3-knob hand wheel was pretty straightforward. Let me show you how I did it. So just to give you a sense of scale, that wheel is about an 8.5-inch diameter or 210 millimeters. So I had my brother Andy helping me, and we decided to fill in the hole first by welding it, but that did not work out because we found out that it's cast iron and we noticed a small little crack. So we decided to mill the holes first. Now here I'm using my dad's Bridgeport milling machine, but I think this could be done at a drill press if you had proper work holding, the correct bit or an end mill, and the right speed. Cast iron is actually pretty easy to machine. The problem with welding it is if it gets hot, it cracks, which we did notice a small crack in that weld. Now you can preheat it, then do the weld, and then let it cool slowly like in sand or something, but I didn't want to take any chances. And so as you can see here, I first created or milled a counterbore and then drilled a hole, but not all the way through. Of course I did one at a time, milling the counterbore first, then drilling the hole, and then I would move it to the next position. And the beauty of a mill is that you don't get any flex, and that end mill will cut that counterbore nice and clean, and then I'm in the same position to drill the hole for the tapped thread. And I sincerely apologize for the shaky video. I forgot my tripod, but I think you can see what I'm trying to do here. So I'm just using the mill to create those threads by just putting pressure on the handle, similar to a drill press, and turning the chuck by hand to cut those threads. Cast iron is awesome to work with. It cuts really easily. I started with a tapered tap, which starts threads easily, finished up with a bottoming tap, which gets threads almost all the way to the bottom. And boom, that is what I was after. And I'll show you how I dealt with that hole, the original hole that was in the front, here in a bit. So my workbench is made of ambrosia maple and bubinga, but I didn't have a big enough chunk, so I found this camphor that a buddy from Hawaii sent me, and I hadn't used it, needed something special. I thought the tone would match really well, and when you cut it or plane it, it produces this amazing scent, kind of a minty spice. Anyway, I think that's going to work. I typically stay away from burls for something like this because they're not very stable and they can crack, but that would be the worst that could happen. But the best thing that can happen would be that they don't crack, and look at that. That is going to look amazing, right? And see, that color or tone will match that bubinga well. So out of this beautiful camphor, I'm going to turn a few knobs, and I need to start by tilting the blade to make this octagonal. And an easy way to make that octagonal, we tilt the blade at a 45, raise it all the way up, set the blank in place, and bring the fence over right to it. Just like that till it makes contact. That is the distance that you need. Lock your fence down, right? And then you can lower the blade, of course. You don't need it protruding that high. We just needed the teeth to engage the blank to set up that distance. That's it. We're ready to go. And like I used to tell my students, if you don't feel comfortable with anything I'm doing or anything that you see anywhere, just don't do it. For me, this is perfectly safe. You can see that the push blocks help hold it down securely. And the last cut is really the only one that's a little sketchy because you have less contact. But you can feel it when it registers and simply make the cut. Beautiful, yeah? I decided to make another knob for my tail vise, so I need 4 knobs total, so I made a little extra. And okay, by now, if you watch many of my videos, you've seen this a few times. This is such an easy way to find centers of a board or a blank, or like I'm doing here with this octagonal piece. I can just make a mark, flip it over. If those marks don't line up, I simply go in between. Then we can try that again after an adjustment, and boom, dead center. So now we can simply mark the end, rotating it 180, that lines up. rotate 90, do it again, boom. Technically, you could do all 8 surfaces just to get a good average of the center. That's awesome, yeah. Now, it's probably not imperative that you get dead center on this because you're going to turn it on a lathe and it's going to center anyway. But this little device is super cool. So you have this little thimble and it houses this lens. And that lens, when you look inside, it'll show this magnified set of crosshairs. You can line that up with your pencil mark, then replace it with this hardened centering punch, and bam, just like that. Beautiful little tool. All right, so here I am at my Atlas metal lathe. Now, it's not ideal to turn wood at a metal lathe, but it works. I'll admit it is kind of slow, but I absolutely enjoy the process. And here I'm just marking out for several knobs. And you can see how I had to cut that, in steps rather than one fell swoop with a round nose tool or a gouge. All right, so here's the original knob, and I just needed to make some kind of a profile so I could sand that funky cove. This piece of poplar was a sample for a thumbnail that I did a while back. I'm not really sure what, but with it I could adjust it slightly. Now, I'm not sure where I got this roll of loop. It's the loop part of the hook and loop, I believe. Or maybe it's a hook, I'm not sure. Anyway, yeah, it's probably the hook. Anyway, this stuff is amazing. So I can put it on this profile that I made. I can score it slightly so it'll bend easier around those corners. And bam, I have a beautiful sanding block. Now, I get it. A lot of people are laughing at the way I'm doing this on the lathe. I don't have a wood lathe, right? But I can do things on a metal lathe that you can't do on your wood lathe. So I've got that going for me. All right, so these are turning out great, and this is exactly what I wanted. All right, fantastic progress. And since I don't do this very often, I have to think a little bit. I need to drill into the ends of them, but the ends have a counter bore, like this original one. Counter bore and then a through hole. And so what I'm going to do, while it's still chucked up and centered, although I could chuck them up individually, I suppose that'd probably be easier. See, I'm having to think here. My initial plan was to use a steady rest here and put a chuck here with a drill bit. And that way I could do a counter bore and a through hole and then cut one off and repeat the process. But lots of ways to do things. Lots of ways to do things wrong too. All right, let's address that original hole in the hand wheel. And if you look close, you can see that little hairline crack in the weld. And I didn't want to be chasing my tail if one of those spokes cracked, so I decided to go with this stuff. Plumber's epoxy. You can see there on the right, I made a couple of samples I added some pigment to try to get the color correct. And this stuff dries hard and machinable in about an hour. It's not very pretty yet, but we'll address that. And here I'm creating a counter bore at the end of this knob, and I'm going to make another video showing how I made this steady rest. And I also drilled a 5/16 plus hole all the way through, or 21/64. This is awesome. And at this point, I can start to do the final sanding. And I'm not going to show the entire process because I'm making another video on the finishing process, something that I learned from my buddy David Bedrosian. It is fantastic. What do you think? That's going to work, yeah? All right, at this stage, I have all my knobs turned. I actually made 4 of these because I made one for my end vise, right? And you'll see that these have this bushing, right? To get that knob away from the radius part of the wheel. So I need to make some of these. And it's a pretty common item. It's 1/4 inch thick. These are 3/4 diameter with a 5/16 interior hole. And as I started looking in some of my stuff, I did realize that I had some larger ones, and then I actually found 3 of these, and those would work. Those would fit right in there, I believe. And they protrude just enough to be able to get the knob on there, something like that. However, I'm gonna go ahead and turn mine, but I'm not gonna really show it because I'm going to assume that not every woodworker has a metal lathe, but you could find these pretty easily. I would suggest maybe a hardware store or a McMaster car, but you'll need those. But real quick, I am going to show this part because I love this process that I learned from my dad. So I've chucked up this round bar and I've just got it close using these guides, right? Those concentric circles. And then I can use two keys and they oppose each other. And you can see that I'm about, probably about 8 thousandths. Let me move this a little bit. Oops, wrong way. So you can see that from some arbitrary number on the dial, I'm moving about 8 thousandths each direction, right? So that area right there is my 0 point. And so I can use two opposing chuck keys, tighten one, loosen the other, till that zeroes in right in there. Boom, look at that. Within a half thou, just like that. I love that process. And yes, of course, if you have a 3-jaw chuck, you don't need to do this. I don't have a 3-jaw chuck. I've already drilled a hole deep enough to get 3 of these, and after adding some Dykem marking fluid, I can cut these, and boom, I have 3 of them. This is such a fun machine to use. So I decided to clean up this hand wheel. It had some bits of glue and discoloration, and I also wanted to smooth out the epoxy. Now, of course, if you don't have a metal lathe, you wouldn't be able to do it like this, but you could easily do it by hand with sandpaper and some Scotch-Brite, steel wool, or whatever you have. I was actually surprised how hard and dense that epoxy was. It was easy to turn on the lathe, but it held its shape really well. I've never used it before, but it seems like it would have a lot of uses in the shop. Really good stuff. A funny thing to note is that when I initially matched the epoxy, it matched pretty close. And then as I shined and polished this up, that metal, that cast iron got lighter, and then it didn't match. But you know what? It's fine for me. My main objective was getting that front single knob out of the way so I wouldn't be, knocking my leg anymore. And I absolutely love projects like this where I get to work on my dad's milling machine and my metal lathe. Super, super fun project. And here's the original knob. Of course, it went here, but the ones I made about a 1/4 inch longer, slightly bigger in diameter, so a little bit bigger. This feels a little bit dainty, but this feels much. Oh, that feels good. All right, so here's this beast when it was brand new with that single knob on the front vise. I loved it, but I love improvement as well. And one thing to note that I hadn't anticipated is that with that added weight around the perimeter of the wheel, it increased the inertia, I guess, and that thing just spins effortlessly. I absolutely love this. Hope you got something out of this video. As always, thanks a ton for watching. Please remember to subscribe. Ciao.